Picture a herd of wildebeest grazing peacefully on the African savanna. Suddenly, two figures appear on the horizon: human hunters. No weapons, no horses, just two people. The wildebeest bolt in panic, sprinting away at 40 miles per hour. The humans begin to jog after them. Now here's what makes this story remarkable: the humans don't need to catch them. They just need to not stop. In a few hours, something remarkable happens. The antelope, designed for explosive sprinting, is forced to stop. Its internal temperature rises as it overheats. Its brain demands it stop. And the human hunters arrive, at a steady, unstoppable jog, ready to claim their prey. This is the persistence hunt. And it may be the most powerful hunting technique our species ever developed. Why were humans built to outrun every animal on Earth? Most animals have a critical limitation: they can't regulate their body temperature as efficiently as humans can. When a cheetah sprints at full speed, its body temperature spikes rapidly. A human, by contrast, has one of the most effective cooling systems in the animal kingdom: sweat glands covering nearly the entire body surface. While a horse loses heat through heavy panting that requires it to stop, a human can shed excess heat while still moving. We have approximately 2 million sweat glands. Most mammals have a fraction of that. This means we can dissipate heat at a rate that lets us keep moving when other animals must stop and rest. The physics are brutal and simple. Every animal generates heat with every muscle contraction. Sprinting generates heat faster than it can be expelled. Humans generate heat at roughly the same rate as other animals during sustained aerobic exercise, but we shed it far more efficiently. When a gazelle's core temperature rises to dangerous levels, its survival mechanism forces it to stop. When a human's core temperature rises slightly, we simply produce more sweat and keep moving. In the evolutionary arms race between predator and prey, humans found something extraordinary: time. By maintaining a steady aerobic pace of 6 to 8 miles per hour, something any healthy human can sustain for hours, early hunters could push prey animals past their thermal breaking point. The animal would collapse from heat exhaustion, and the hunters would walk up and dispatch it with basic tools. This strategy wasn't just effective. It was revolutionary. Fossil evidence from Kenya and Tanzania shows that Homo erectus had anatomical features optimized for endurance running by 1.7 million years ago: long legs, shortened toes, wide buttocks for gluteal power, and a narrow waist for efficient respiration. These are not features designed for walking. They're features designed for running. And they represent one of the most important evolutionary transitions in human history. What could we actually outrun? The evidence is surprising. In distance races, humans can beat horses over sufficiently long courses. In temperatures above 95 degrees Fahrenheit, humans outperform horses in endurance events consistently. The famous Welsh Marathon shows humans finishing ahead of horses in races over 22 miles. A fit human can maintain a 10-minute mile pace for 26 miles. A cheetah would overheat in minutes at that pace. An antelope sprints for 30 seconds and must rest for 30 minutes. A human can jog for 3 hours straight. The evolutionary payoff was enormous. Meat from persistence hunts provided dense calories that fueled the growth of larger brains. Cooking food over fire further enhanced nutrient absorption. The combination created a feedback loop: better nutrition led to larger brains led to better hunting techniques, better hunting led to even better nutrition. This cycle may have driven the threefold increase in human brain size over 2 million years. And the legacy lives on. Today, ultramarathon runners complete 100-mile races through mountains and deserts. Elite athletes maintain paces that would exhaust any other animal over the same distance. The human body, shaped by millions of years of persistence hunting, is still fundamentally designed for endurance. You might not feel like a marathon runner right now. But deep in your DNA, you carry the physiology of someone built to simply not stop.